Researchers from the University of Massachusetts Amherst have created smart pajamas. Because when you think of how you're sleeping at night, it's not something you typically know. Led by Dr. Trisha Andrew, a multi-disciplinary research team at the Wearable Electronics Lab, or WE Lab, recently sewed 5 different sensors into a loose-fitting silk pajama shirt to monitor heartbeat and breathing. The shirt can even tell you what position you're sleeping in. The self-powered sensors provide improved access that could be used to help improve sleep patterns. For example, the PJs can tell if you're breathing, or if you have sleep apnea, or if the position you typically sleep in is limiting your sleep quality. The sensors are powered by a small, fiber-based supercapacitor made by the WE Lab that is sewed onto the garment. It communicates via Bluetooth and can run for up to 8 hours on a single charge. They're even machine washable and can withstand 30 to 40 wash cycles. What I found interesting is that the sensors can be sewn into pretty much whatever you'll want. If anything, it could drastically improve sleep studies, which could even be performed at home. I mean, I'm not sure if you've seen those at-home kits. But let's just describe them as a little busy, a little cumbersome. No, they're busy. Dr. Andrew doesn't have a time as to when they'll be on the market, but she is looking for investors to help expedite the process.
If any investors are out there, I'm happy to talk to you.
Remember, if you have better sleep, you typically have a better quality of life. That's what they tell me anyways. Here you go. Researchers from the University of California, Berkeley have created Blue, a robot designed to fold towels.
You're my boy, Blue!
Luckily, there's a little more to the equation, as Blue, which resembles the frame of a CrossFit bro, was designed to master basic but intricate human tasks, like folding the laundry or making a cup of coffee. If you watch it, it actually kind of looks like that Gap worker on the first day of the job. Nervous, fidgety, but there's promise. Typically, when we think of robots, we think big industrial machines moving car frames and tending machines. Blue was designed to use artificial intelligence and deep reinforcement learning to master human tasks using trial and error or demonstration, like when a human teaches it how to do something. The researchers also developed Blue to be affordable and safe enough so that it could one day be found in every home. Right now, Blue's components total less than $5,000 to manufacture and assemble. But what's the markup? What's that gonna be? I feel like it's gonna be higher. The robot has a wide range of motion with joints that are designed to mimic human movement. And it's also designed to expend energy much like a human. For example, it can hold up to 2 kilograms with its arms fully extended, but it's, quote, thermally limited. Like a human, it can exert a force well beyond the 2 kilogram limit in quick bursts, until its thermal limits are reached and, Blue needs to take a breather. Next, the team will work on improving Blue's durability, and the startup, Berkeley Open Arms, will try and figure out how to manufacture it on a larger scale. Here you go. The future of the flying car remains suspect. We've seen some interesting concepts and prototypes, and as some companies start taking pre-orders, it's about time for researchers to come out and trash the idea. Researchers from the University of Michigan's Center for Sustainable Systems and Ford Motor recently published an environmental impact study that determined that you are better off in a car for a short commute, but a flying car could be a better choice for longer commutes. For the sake of the study, researchers specifically looked at VTOLs, or electric vertical takeoff and landing aircraft. The report looks at primary energy and greenhouse gas emissions of VTOLs compared to ground-based cars. VTOLs, which take off and land like a helicopter and then fly like a plane, are efficient when cruising, but consume a lot of energy for takeoff and climb. So it all comes down to trip distance and, whether or not you're carpooling. Will that be the same when you're in the air? The researchers analyzed primary energy use and greenhouse gas emissions during the 5 phases of VTOL flight: takeoff hover, climb, cruise, descent, and landing hover. These aircraft use a lot of energy during takeoff and climb, but are relatively efficient during the cruise phase, when they're traveling at about 150 miles per hour. As a result, VTOLs are the most energy efficient on long trips, when the cruise phase dominates the total flight miles. The researchers found that for trips of 62 miles or 100 kilometers, a VTOL carrying a pilot and 3 passengers had lower greenhouse gas emissions than cars. Emissions were 52% lower than gas vehicles and even 6% lower than battery electric vehicles. For shorter trips, like anything less than 22 miles, vehicles actually used less energy and produced fewer greenhouse gas emissions than VTOLs. That's important when you consider that the average vehicle's commute is about 11 miles. Of course, the VTOL would also be much faster. I mean, it would complete the 62-mile trip about 80% faster than a car. But I mean, who knows if that'll be the case once the sky is just as congested and people still haven't stopped texting and driving. I'm David Manti. This is Engineering by Design. Here you go. Oh, I need to stretch.